desk asking for a room. The manager says, "Sorry, all the rooms are occupied," and that's the end of the story. But now, says Hilbert, let's imagine a hotel with an infinite number of rooms, and let's suppose, once again, that all the rooms are occupied. This fact has to be clearly appreciated. There is not a single vacancy throughout the entire infinite hotel. Every room already has somebody in it. Now suppose a new guest shows up at the front desk asking for a room. "No problem," says the manager. And he moves the person who was staying in room number 1 into room number 2. The person who was staying in room number 2 into room number 3. The person who was staying in room number 3 into room number 4, and so on out to infinity. As a result of these room changes, room number 1 now becomes vacant, and the new guest gratefully checks in. But remember, before he arrived, all the rooms were already full. It gets even worse. Let's now suppose, Hilbert says, that an infinity of new guests show up at the front desk asking for rooms. "No problem," says the manager. And he moves the person who was staying in room number 1 into room number 2. The person who was in room number 2 into room number 4. The person who was in number 3 into room number 6, each time moving each person into the room number twice his former room. Now, since any number multiplied by 2 is always an even number, all of the guests wind up in the even-numbered rooms. As a result, all of the odd-numbered rooms become vacant, and the infinity of new guests is easily accommodated. In fact, the manager could do this an infinite number of times and always accommodate infinitely more guests. And yet, before they arrived, the hotel was already full. As a student once remarked to me, Hilbert's hotel, if it could exist, would have to have a sign posted outside. "No vacancy. Guests welcome." But Hilbert's hotel is even stranger than the great German mathematician made it out to be. For just ask yourself the question, what would happen if some of the guests start to check out? Suppose all of the guests in the odd-numbered rooms check out of the hotel. In this case, an infinite number of people have left the hotel, indeed as many as remained behind. And yet, there are no fewer people in the hotel. The number is just infinite. Now, suppose the manager doesn't like having a half-empty hotel. It looks bad for business. No matter. By moving the guests as before, only this time in reverse order, he converts his half-empty hotel into one that is bursting at the seams. Now, you might think that by these maneuvers, the manager could always manage to keep this strange hotel fully occupied. But you'd be wrong. For suppose the guests in room numbers 4, 5, 6, and so on check out. At a single stroke, the hotel would be virtually emptied, the guest register reduced to but 3 names, and the infinite converted into finitude. And yet, it would be true that the same number of guests checked out this time as when all of the odd-numbered guests checked out. Can anybody believe that such a hotel can exist in reality? Hilbert's hotel is absurd. Now, since nothing hangs on the illustrations involving a hotel, the argument can be generalized to show that the existence of an actually infinite number of things is absurd. Sometimes people react to Hilbert's hotel by saying that these absurdities result because the concept of infinity is beyond us and we don't really understand it. But this reaction is mistaken and naive. As I said, infinite set theory is a highly developed and well understood branch of mathematics. And these absurdities result because we do understand the nature of the actual infinite. Hilbert was a very smart guy, and he knew very well how to illustrate the bizarre consequences of the existence of an actually infinite number of things. Really, the only thing that the critic can do at this point is to just bite the bullet and say that a Hilbert's hotel is not absurd. Sometimes critics will try to justify this move by saying that if an actual infinite could exist, then such situations are exactly what we should expect. But this justification is inadequate. Hilbert would of course agree that if an actual infinite could exist, then the situation with his imaginary hotel is what we should expect. Otherwise, it wouldn't be a good illustration. But the question is whether such a hotel is really possible. Moreover, the critics can't just bite the bullet when it comes to situations like the guest checking out of the hotel. For here, we do have a logical contradiction. We subtract identical quantities from identical quantities, and we come up with non-identical results. And that's why subtraction of infinity from infinity is mathematically prohibited. But while we may slap the hand of the mathematician who tries to break the rules, we can't stop real people from checking out of a hotel. So I think Al-Ghazali's first argument is a good one. It shows that the number of past events must be finite, and therefore the universe must have had a beginning. Now, Al-Ghazali had a second independent argument for the beginning of the universe. So those who deny that the universe began to exist have to refute not only his first argument, but his second one as well, since it's independent of the first one. The series of past events, Al-Ghazali observes, has been formed by adding one member after another. The series of past events is like a sequence of dominoes falling one after another until the last domino, today, is reached. But he argues no series which is formed by adding one member after another can be actually infinite. For you cannot pass through an actually infinite number of elements one at a time. Now this is very easy to see in the case of trying to count to infinity. No matter how high you count, there will always be an infinity of numbers left to count. But if you can't count to infinity, how could you count down from infinity? This would be like someone's claiming to have counted down all of the negative numbers, ending at 0, -3, -2, -1, 0. This seems crazy. For before he could count 0, he would have to count -1. And before he could count -1, he would have to count -2. And before he could count -2, he would have to count -3, and so on back to infinity. Before any number could be counted, an infinity of numbers will have to have been counted first. You just get driven back and back into the past so that no number could ever be counted. But then the final domino, so to speak, could never fall if an infinite number of dominoes had to fall first. So today could never be reached. But obviously here we are. That shows that the series of past events must be finite and have a beginning. Some critics have responded to this argument by pointing out that even in a beginningless past, every event in the past is only a finite distance from the present. Compare the series of negative numbers. -3, -2, -1, until you finally come to 0. Now, even though the series of negative numbers is infinite and beginningless, nevertheless, any number you pick, say -11 or -1 1 billion or whatever, any number you pick, n, will be only a finite distance from 0. But the finite distance from any past event to the present is easily crossed, just as you can count down to 0 from any negative number that you pick. This objection commits a logical fallacy called the fallacy of composition. This is the fallacy of confusing a property of a part with a property of the whole. For example, every part of an elephant may be light in weight, but that doesn't mean that the whole elephant is light in weight. In the case at hand, just because every finite part of a series can be counted down or crossed, doesn't mean that the whole infinite series can be counted down or crossed. The critics have committed an elementary logical fallacy. The question is not how any finite part of the past can be formed by adding one event after another, but how the whole beginningless past could be completed by adding one event after another. Al-Ghazali sought to heighten the absurdity of forming an infinite past by giving illustrations of various absurd situations that would result if it could be done. For example, suppose that for every one orbit that Saturn completes around the Sun, Jupiter completes 2. The longer they orbit, the further Saturn falls behind. If they continue to orbit forever, they will approach a limit at which Saturn is infinitely far behind Jupiter. Of course, they'll never actually arrive at that limit. But now turn the story around. Suppose Jupiter and Saturn have been orbiting the Sun from eternity past. Which will have completed the most orbits? Well, the answer is that the number of their orbits is exactly the same. Infinity. Now, don't let somebody try to slip out of this argument by telling you that infinity is not a number. In modern mathematics, it is a number. It is the number of the elements in the set of natural numbers, 0, 1, 2, 3, and so forth. So the number of the orbits completed by Jupiter and Saturn is exactly the same. Infinity, even though for every orbit that that Jupiter completes, or rather the Saturn completes, Jupiter has completed 2. And that seems absurd because the longer they orbit, the greater the disparity between them goes. So how does the number of orbits magically become equal by making them orbit from eternity past? Another illustration. Suppose we meet someone who claims to have been counting down from eternity past and is now finishing. -3, -2, -1, 0. Why, we may ask, is he just finishing his countdown today? Why didn't he finish yesterday? Or the day before that? After all, by then an infinite amount of time had already elapsed. So if the man were counting at the rate of 1 number per second, he's already had an infinite number of seconds to finish his countdown. He should already be done. In fact, at any point in the past, he has already had infinite time, and so should already be finished. But then at no point in the past can we find the man finishing his countdown, which contradicts the hypothesis that he has been counting down from eternity. These illustrations only strengthen Al-Ghazali's claim that no series which is formed by adding one member after another can be actually infinite. Since the series of past events has been formed by adding one event after another, it cannot be actually infinite. It must have had a beginning. And so we have a second good argument for premise 2 of the Kalam cosmological argument, that the universe began to exist. Now, before I share with you the scientific arguments in favor of this premise, let me ask if there are any questions about the philosophical arguments that we've just shared. What you're saying is that the same philosophical arguments against the universe's existing for infinite past time would apply against God's existing for infinite past time. And Al-Ghazali would agree with you, and therefore would say God has not endured through an infinite series of moments prior to creating the universe. Rather, he will say that time itself